All right, let's see. Hi guys, quick question. So raise your hand if you know who said that quote. Okay, I see you prefer your cloud over your philosophy. Cool. What if I told you, let's start with a hypothesis, that there's an AWS service that is typically used for monitoring, security monitoring, but it could actually lead to a security risk. So it could actually expose somehow the AWS account that it's supposed to be in. So that service was CloudWatch. It's not Cognito, contrary to what the title said. And if you know CloudWatch dashboards, it turns out that they allowed unauthenticated actors to, let's say, see beyond performance data, the stuff that's usually in dashboards. So the main idea that I want to focus here today is security monitoring solutions sometimes can introduce security risk. And I think that's a little bit interesting. That's going to be an example case. So I'm definitely not the first one to come across a situation like this. Rory McEwen recently gave a talk in B-Sides Dublin about this. He specifically focuses on Prometheus and Jaeger. So go watch this one. It was a good inspiration for me, gave me some good ideas, and yeah, shout out to Rory. Cool, what are we going to talk about? We're going to start with the usual introductions, you know, the boring who am I's and everything. We're going to see how it all started, how our research came to be. Talk a little bit about how that normally works, you know, what the feature we're talking about actually is. And then we're going to look at the attack, right? The actual exploitation steps, why this worked, how exactly it worked, how bad is it. And once we get to the bottom of it, once we understand the root cause, we're going to be able to, again, understand how to remediate it, how to fix it. So who am I? Hi guys, my name is Leo. I'm a senior security consultant at ReverseSec. I come from London, UK. ReverseSec used to be with Secure Consulting, if you remember that name. You might also remember me from last year. I was literally next door talking about Kubernetes. And we have a service that I lead. It's called Attack Path Mapping in ReverseSec. So what do I do? Mostly security exercises, offensive security exercises, kind of like purple teams, you know, large-scale projects. I don't want to say red teams. And lots of technical research, right? So, which has thankfully led to a lot of conference talking. You'll see some of these fancy logos over there. Topics, including AWS Active Directory, Kubernetes, vulnerabilities in web apps, in mobile apps. And I've been lucky to have found some vulnerabilities in stuff from IBM, Cisco, WindVision, Xiaomi, and AWS, and that's the one we're going to talk about. Unfortunately, no CV was assigned for that one, but it is what it is. So if you're wondering what do I really do, the answer is PowerPoint diagrams. So our story starts with a scan. So I was on that job, the cloud security review, cloud assessment, let's say, testing a couple of accounts, and as part of the automated phase, I ran a couple of scanners, and one of them spits out a bug, spits out an alert, and the alert looked a bit like that. There's a CloudWatch dashboard, which is shared publicly. I personally didn't even know you can share a dashboard, but I found out. And the warning, the reason why that scanner threw that alert was that, you know, exposing stuff publicly is bad practice, and, you know, bad, please avoid. So I was a little bit curious. I was wondering if there's any impact to that, if there's any security risk with that. So I went to the documentation page. You'll see that linked over here, and there's a subtle hint over there. Early in the page, literally in the top of it, there's this warning, there's this orange dialogue that says, the people you share the dashboard with are going to get some permissions into the account, which kind of makes sense if you think about it. They need to access the data. And if you scroll down on that page, you see the exact permissions that they're going to get. They get 3 CloudWatch permissions and an EC2 describe tags permission. So that last one, I don't know about you, but it looked a bit odd to me. It isn't necessarily something CloudWatch dashboard viewers should be able to do, describe the tags. So I decided to dig a little bit deeper. So once you share a dashboard, once you share it publicly, you get a URL. You get a URL like that, you see the context parameter over there at the end, and you share that with the person you want to share the dashboard with, and when they click it, they look at an application which looks like this. And you get all the widgets and data starts flowing. But the important thing is there's no authentication going on. At least I didn't notice any authentication. It isn't very visible, but there must be some authentication. So if you zoom in, if you fire up your proxy, you will identify 2 requests. The one of them is towards the Cognito Identity Service and the Get ID API. And there's this field called an identity pool ID, which is being sent to the endpoint, and in return, the client gets an identity ID. And then the second request to a different endpoint of the Cognito Identity service. That identity ID that we retrieved previously actually gives us some credentials, and that's the big redacted red blob over there. And these credentials, I was thinking, I can load them into my AWS CLI and then proceed to run easy-to-describe tags. So, through this very quick analysis, I realized that, it's quite simple, it's just 2 API calls to that Cognito service. And then I thought, what Cognito service? Like, how is Cognito even related to all of this? I wasn't so familiar with that, so it turns out this is the typical way to do things in AWS land. If you want to share AWS data, AWS resources to others and give them temporary credentials, you do it with Cognito. And this is a typical authentication flow. It's called enhanced, or simplified authentication flow. And all your application needs is an identity pool ID. And that identity pool is a Cognito resource, but we'll see about that in a second. That's the diagram. This is how it works. It's quite simple, actually. These are the 2 requests that we identified. So that identity pool ID, which the application needs, is in the context parameter. And you'll see it looks a bit like an encoded JSON. It is actually an encoded JSON. If you decode it, you see some of the fields. We know already that the I field is that Cognito identity pool ID that the client needs. What about the other ones? Some of them we can already infer, like the R looks a lot like a region, the M is probably the sharing mode, the O looks like an ARN of an IAM role, so we quickly suspect that this is the IAM role that the user gets. The other ones aren't really important right now, so I'm going to skip them. Cool, that's not the point. Our point was the EC2 tags. So like I said previously, I got the credentials from my browser, loaded them into my AWS CLI, and then did the describe tags operation, and I got an error. And that error was unauthorized operation. No session policy allows the action. So I was like, what's going on here? What you do in these cases is you experiment a little bit. You set up a lab just to try things out, see it from the building side before the breaking side. And I actually made some pretty good observations. The first one was that it's not a matter of lacking documentation. That security risk is highlighted to the user many times. So I cannot blame AWS for not stressing that enough. They see it in the documentation page that we saw previously. They see it when they start sharing a dashboard, and they even see it when they're done with sharing a dashboard. So they do warn you. The second observation is that, again, Cognito, as per the documentation, is the service that does the heavy lifting for the authentication part of the dashboard. It boils down to 3 resources, 3 Cognito resources, and the IAM role. And by the way, I found out on Friday on another Cloud Village talk that these are called shadow resources. So maybe there's a few more stuff that you can do with these resources. They're in your account. You can explore them. You can see how they look like. Another observation I made was that all of that is actually done by the console. Is actually done by the CloudWatch service on the client side. So the JavaScript SDKs is invoking these APIs. It's the ones highlighted over there. And importantly, there's no user involvement. And why is that important? Because if you're in security, you know very well that if we leave the user some room to make mistakes, they will make mistakes. So it's best if the client handles that. So eventually, from that reproduction, I got to understand how this whole thing works. This is the viewer flow, that resource dance, but I'm going to break this down for you step by step. So the viewer first gets that link, that dashboard link, and that link includes a context parameter that we saw previously. So the client-side code, the JavaScript code, is being fetched by the browser from an Amazon CDN, and then it proceeds to make 2 requests, the 2 requests that we saw in the proxy, towards the Cognito identity service. It gets the identity and trades that for credentials. With these credentials now authenticated, the client proceeds to get the manifest. The manifest is sort of like a blueprint for the dashboard, so it includes like positioning information, like here's widget A, here's widget B, and it fetches the names in that manifest, the names of alarms and metrics data. And having these names, it then proceeds to start fetching all the data. So the data starts flowing in your dashboard and all your fancy visualizations, which is cool, but it doesn't really answer our problem. We had that error, if you remember. We still don't know why describe tags doesn't work. So turns out it wasn't just me, there were others wondering about this too. I bumped into this issue in the AWS JavaScript SDK repository. which does have a reply from the developer themselves that claims that this is intended behavior. And they link to the documentation where you can actually read that Cognito applies a scope down policy for your own security protection, for the security of the user. So they kind of like, lie to you a little bit, and they downgrade your permissions via an inline session policy. So let's take a step back, go back to basics and see how IAM sessions work, what are the effective permissions that you get. So the effective set of permissions that are granted to any session are those in the intersection of the identity-based, the resource-based, and the session-based policies. In our context, in our use case, the IAM role of the dashboard is granted all of these permissions, all 4 permissions, so that's fine. The tags themselves, the resource, do not restrict who's allowed to, which principal is allowed to list them, so there's no resource-based policies in play here. But the inline session policy that is being applied by Cognito does leave out the EC2 permissions. It does allow CloudWatch and Lambda, but it leaves this out. So the effective policy is only these 3. EC2 describe tags is outside of that. And this is why we cannot list the tags. So what if we could instead use a basic flow? I was just wondering, theoretically speaking, if we could do a basic authentication flow against that Cognito resource, then the identity policies would be exactly the same. The client could ask explicitly for the IAM role that they desire, which, by the way, we know that from the O parameter. So the session policy would be exactly the same as the identity policy, because we said that explicitly. We want that IAM role. So there would be no scope down, and the effective policy would include the EC2 describe tags. So the question becomes, can a dashboard viewer initiate a basic authentication flow against the dashboard Cognito resources? Spoiler alert, the answer is yes, and let's see how that works. This is the complete flow, but once again, let's look at it step by step. So the attacker has the context parameter from that link, and from the context they extract the ARN of the IAM role, that's the O field, and the identity pool ID, which is the I field. With this identity pool ID, they proceed to get an identity from Cognito service, and then they trade that identity for an OIDC token, an OpenID Connect token. Now, that next step is the most important one because they trade the token for temporary credentials, but they explicitly specify the IAM role, if you see the ARN over there. And that means that we do the classic flow, and we get the credentials back, load them in our AWS CLI, perform the operation, and voila, we get the tags. So that confirmed our exploitation scenario end to end. What we've got here, we have a viewer who went from unauthenticated, from a dashboard viewer, all the way to listing EC2 tags, all by just knowing a URL, that URL of the CloudWatch dashboard. And URLs like those are not hard to find, so I went hunting. On the right-hand side, you see a very simple Google Dork. I found something like 20 or so URLs like that out there on the internet. And then I searched in other services like URL scan, and I found a few more, let's say 10 more there. Not too many exposed on the internet. And this is where it became a little bit fun, a little bit interesting. So I started looking at those just to see some real-time data flowing, just to try and understand what the heck am I looking at. It was a little awesome adventure, let's say. I'm going to show you a couple of them. The EWN is a publicly accessible dashboard from an Australian weather event monitoring platform, monitors for extreme weather conditions. And then Munzee is a global scavenger hunt game, so there are QR codes spread around the world. There's one in Antarctica, actually, that users can go and scan and get some points. So obviously I didn't perform the full attack at those. That would be a little bit dodgy. But I had this sad realization that the summary of dashboards shared with any form of authentication. By the way, there are 2 other modes of authentication. There's public, and then there's username and password sharing, and SSO sharing. So the summary of those is fewer than the ones shared publicly. So Denzel is a little bit disappointed because, people do choose convenience over security. That's the easiest one. That's what they end up doing. So, at this point, I guess I should address the elephant in the room. You might be thinking, is that such a big deal? We can list the EC2 tags. Frankly, it isn't really. I agree with you if you're wondering. Amazon clearly advises in many locations that you should not be putting sensitive data in the EC2 tags. But then again, if you're doing any sort of cloud security assessments, you know that this isn't necessarily followed always. We've seen a lot of clients that have put all sorts of sensitive stuff in there, anything from PII to contact details of resource owners, plain text credentials sometimes. Another observation is that, remember, the permissions of that IAM role, those 4 permissions, they're canned. It's a fixed set. So it's being set by the Amazon code, by the CloudWatch service, which means that users will not modify it manually. If it works, unless they want to add more features. So I started wondering, are there any use cases where users would be suggested to add more permissions to that IAM role so that an attacker could then have more permissions and effectively mess it up themselves? And it turns out there are. There are a few features, 2 features specifically, 2 use cases where the users are advised to add more permissions. It's when they need to add log table widgets or when they need to add custom widgets. And these are the permissions that these result to. For log table widgets, you need to add to the IAM role these 4 logs permissions, which aren't that interesting. But if you want to add custom widgets, you actually need to give the viewer Lambda invoke function permissions. And that's a little bit more interesting. And I'll show you in a second why it's a little bit more interesting. But do bear in mind that the documentation also suggests that you should lock down these permissions to only the specific resources. Again, the user might mess that up. They might add an asterisk over there instead of these specific permissions, but they were told, they were advised against that. Now, Lambda functions are a little bit more interesting because there's this attack which Scott Piper talked about way back in 2020, which is called denial of wallet. And the idea is that if the attacker only has 1 Lambda function that they can invoke, they hammer that down, they execute that function as many times as they can in order to incur financial charges to the resource owner. So effectively put them out of pocket. So maybe that's possible as well. Why is this all happening though? I was wondering about this, and it turns out it is preventable. It turns out that there is a way to block basic authentication flows altogether. There is that field in the create identity pool request. It's called allow classic flow. It's the one highlighted over there. And you can set that. If you set that to false, obviously you're blocking this attack altogether. But in the configuration of the CloudWatch dashboard, of the Cognito resource supporting the CloudWatch dashboard, we see that this field has a dash value. I don't know if you can see it, it might be a bit too slow, but it's not a yes or a no. It's supposed to be a Boolean field, but it's dash. So it's a little bit weird. I'm like, let me query that with the API. And things get even more weird because when I queried that field doesn't exist at all. So that sort of confirms that it's in a weird, undefined state. And remember, it's the AWS console that facilitates all that, which means we can see the request. We can see the create identity pool request that is being executed, and we can see if they actually set that field. It's in the browser. If you open the inspector tools, you can see it. It's all public APIs, by the way. The console uses public APIs. There's no internal ones used. And indeed, you'll see over there that the allow classic flow field is not set. It's left undefined. So what we're actually looking at is a combination. It's a logic bug in the console, the fact that that field is not being set, combined with what I like to call a fail open condition within Cognito. And that is what's going to happen to that field if it's not set explicitly. And that combination leads to EC2 tags being exposed to unauthenticated third parties. And you see that asterisk over there because it could also be not just exposure of EC2 tags, it could also be the Lambda invocation permissions, as we saw previously, based on certain conditions. So that fail open behavior in Cognito, again, a bit of an odd observation. So someone had actually flagged that as well. There's this other issue in the AWS CLI repository where someone says, oh, the allow classic flow field is not being set, but that issue has been closed as it was stuck in inactivity. Someone else addressed that previously in that thread, and they said, once again, it's intended behavior, but my interaction with AWS was a little bit more fruitful, and they said that this was indeed a design decision. It was historically chosen when the enhanced flow was introduced in order to maintain backwards compatibility with the classic flow. So they left that, undefined. And how do people create Cognito resources? Like, where is that API call initiated from? I guess there are three most common clients. There's the console, ClickOps. There's the SDKs, including the CLI, which is the Python SDK, and there's Terraform. So we already know that the SDKs, the JavaScript, and I did confirm that with Python. So we already know that the SDKs do not set that field, which means it's left uninitialized and effectively true. So it's insecure. If you do that with the console through ClickOps, if you create a Cognito identity pool just by clicking in the console, you are prompted to explicitly set that. You are given that checkbox. If you leave that empty, if you don't check that checkbox, it defaults to false, which means it's secure behavior. And the same thing happens with Terraform. Terraform behind the scenes default that field explicitly to false. And at that point, I think I had exhausted the public sharing, so I thought I'd pivot and look at the other forms of dashboard sharing, specifically username and password sharing and SSO sharing. So username and password sharing, very quickly, how this all works. You're asked to give email addresses, and the recipients of the owners of these email addresses are going to get an email, and they're going to set up their passwords, and then using this password and the email, they're going to log in and get their dashboard. You are prompted once again that this is going to give them some permissions. It is a little bit softer here. It's just blue. It's not a warning red, like a yellow or orange dialog. So cool, same attack, right? The exact same exploitation primitive. Can third parties get the EC2 tags? So in this case, if you remember, that was the flow. The first step doesn't even work. The first step doesn't work because apparently, according to the error, unauthenticated access is not even supported, which means it's fine, it's secure. The answer is no. But what about intended viewers? What about the guys that have these email addresses that were supposed to look at the dashboard? Can these guys see the EC2 tags? It's not exactly what they were supposed to be doing. They were supposed to be looking at the dashboard, not listing the EC2 tags. So we can't see that. We can't see that through the browser. We can see that request. And in that case, interestingly, the ARN of the IAM role is explicitly set in that request, which means there is no scope down, which means the credentials retrieved by the browser, you don't need to do anything manually. You just grab the credentials from the browser, you load them into your CLI. You don't even need to load them in your CLI. These credentials have the necessary permissions. So the answer is yes. Intended viewers can get the EC2 tags when shared with username and password. What about SSO sharing? SSO sharing makes things a little bit more complicated. Intended viewers, let's look at what happens with them. They are granted a JWT by the SAML provider, and that JWT includes an IAM role ARN, which means that if they have that ARN, they set that explicitly, the browser sets that explicitly, and again, there is no scope down, and the answer is yes. When shared with SSO, intended viewers can still get the EC2 tags out of the account. So just to summarize all the sharing methods and see how, if there's any risk of those, we did initially find that for public sharing, anyone can get the EC2 tags and potentially, Lambda and CloudWatch logs. In username and password sharing and SSO sharing, third parties cannot get these permissions, but intended viewers can. So that's important to remember. And if you're worried, if you just realize that you are sharing a dashboard with someone, don't panic. You don't need to go and delete the dashboard altogether. You only need to unshare it. And if you unshare it, the identity pool for that dashboard gets torn down, it gets deleted, so you're fine. It mitigates the exposure. And interestingly, the other resource, the user pool, persists. So to destroy that resource, you need to unshare the last dashboard. It's a bit of a weird logic there, a condition. So let's talk a little bit about the disclosure process. I found myself in a crossroads. The first option was to have a nice, cool live demo to showcase in a blog post with listing the EC2 tags, a cool exploitation technique. And I was dreaming of adding scanner modules for Scout Suite, Packpool, Prowler, and everything. Or I could disclose that to AWS, be transparent, be okay, and then possibly submit a CFT, possibly go to Vegas, and yeah, I guess you know what I decided. I reached out to AWS in July 2024. Nowadays they're using HackerOne, but before that they had a channel with just email, so it was just email-based communication. Overall, a smooth experience, I would say, and the fix was eventually deployed in September 2024. No CV was assigned to that, and it's not mentioned in the security bulletin, so I don't know if the clients can even find out about this. And what was the fix? They actually set that field explicitly. Now the request has the allow classic flow field, and it's set to false. So they mitigate they completely prevent this attack, and that is the case for all sharing methods. So just a few takeaways before we close. If you're hacking clouds, if you're security testing, I would suggest you go beyond scanner results and try and understand what the true impact of your findings are. If you're building cloud infrastructure, this is a case where default configuration was not secure. So remember that sometimes everything is not secure by default. Do remember that some risks do remain. So AWS patched that one, but intended viewers can still run this attack. And finally, just want to circle back to the main idea that every now and then, security monitoring solutions can actually lead to security risk. And I found that a bit interesting. You'll find all the details about this in the blog post that we published in ReverseSec Labs. You'll find that over there. And that's about it from me. Thank you very much for your time.